Find the area A under the graph of f of x equals x, which is an identity function, over the interval 0 to 4 in 3 different ways. First, use geometry, then compute the Riemann sum using the left endpoint and the right endpoints. First, we will use geometry, and to do that, we would need to sketch the graph of f of x equals x. The line y equals x goes through the origin, and the slope is 1. We're interested in the area under this curve from 0 to 4 only. And so we shade this region under the curve above the x-axis. Using geometry, we see that the area of this shaded region is the area of the right triangle, 1/2. The base is 4, and when x equals 4, the height is 4. And so this is 16/2, or 8. And so we know that the area under the curve f of x equals x from 0 to 4 is 8 using geometry. If we were to use the right endpoints and the left endpoint to set up the Riemann sum, we would need to have the same answer, 8. To compute the area under this curve using the right endpoint so that we can take the limit as n goes to infinity of r sub n. R sub n is the right sum. By the definition, this is the sum at I go from 1 to n of f of xi times delta x, where xi is the right endpoint of each of the subinterval. In this case, the delta x, which is the width of each subinterval, is b minus a over n. b is 4, a is 0, and n is n in this case. We would need to use infinitely many n. There is no finite number of n in this case because n needs to go to infinity, and we can't just plug in infinity in this case. Delta x is therefore 4 over n. Once we have delta x, we can obtain the formula for x sub I. X sub I is always a plus I times delta x. What is a in this case? A is 0, and delta x is 4 over n. And so x sub I is 4i over n. Now that we have x sub I, we can plug this into the function f of x. And so f of xi is simply xi because f of x equals x. But xi is 4i over n. We can then set up the Riemann sum for the right endpoints. And this is the sum as I go from 1 to n. F of xi is 4i over n, and delta x is 4 over n. This sum can be simplified as I go from 1 to n, 4 squared I over n squared. We can bring out 4 squared over n squared because this sum only depends on I. I is the index in this case. And so 4 squared over n squared doesn't depend on I. Inside the sum, we still have I. But then recall that the sum as I go from 1 to n of I is simply the sum of the first n integers, 1 plus 2 plus 3 plus 4 all the way to n. And that sum is n times n plus 1 over 2. Refer to the list of the sum of the first n integers, the first n squared, the first n cubed from the notes. We then simplify this. This is 4 squared over 2n squared times. We distribute n to end up with n squared plus n inside the parentheses. This is 16 over 2, which is 8, times n squared plus n over n squared. And we can simplify this further. This is 8 times n plus 1 over n, because we can factor out the n in the numerator and cancel out one factor of n. And this is r sub n. The limit as n go to infinity of r sub n is therefore the limit as n go to infinity of 8 times n plus 1 over n. We can bring out the 8 in front of the limit, and so we have 8 times the limits at n go to infinity of n plus 1 over n. And as n go to infinity, we can see that this limit go to 1. And so the answer is still 8.